2-3, page 4. Lecture 2-3, page 4. You guys are so quiet. Is it because it's Friday? Yeah, I know, I feel you. I'm ready to get home with my favorite adult beverage too, water. Okay. So let's finish this real quick. So we have 10 ohms. Then I have a 10 and 10 in series. So that's 20 ohms. And over here I have a 10 and 10 in series. That's 20 ohms. And then I have a 10 and 10 down here in series. That's 20 ohms. And then there was a 10 ohm resistor over here. So some things that I told you is the dangling resistor has no impact on the net resistance, so I can just take it off. So when I redrew this, I don't even have to draw that because it does not affect the net resistance. So when I redraw this again, I'm going to have a 10 ohms. The left side is 20 ohms. The right side, because of that dangling resistor being gone, is now 40 ohms. And then I have a 10 here. Are there any questions so far? Okay. So the resistance between terminals A and B is 10 plus 20 in parallel with 40 plus 10. 10 plus 20 in parallel with 40 plus 10. What is RAB? 33.3 ohms. And that was Megan? Yeah. Good job. Megan the Stallion. All right. 33.3 ohms. Any questions? So as long as you have a balanced delta or Y, the formula is relatively easy because you either use RY equals 3R delta or R delta equals RY over 3. So now let's see what happens when you don't have a balanced bridge. A balanced wire delta. This is page 5. So it says here, use two different, well, I don't like the way this is leaning back. You're annoying me. So use two different delta Y transformations to find V1. So one of the ones we could use is right here in the middle, I have a Y. I can change that to a delta. Okay, so that's one way to do this. The other way to do this is over here, I have a delta. And I can change that to a Y, okay? So just because I want to show you both ways, over here I'm going to have 40 volts, 30 ohms, and 10 ohms. Then that delta, I am going to change it to a Y. Where's my pencil? My colored pencil. Not in here. Let's just use this. So then up here, this becomes a Y, like that. Where this is R1, R2, and R3. And this is node A, B, and C. And on the original one, this is node A, B, and C. So this is RC, RA, and RB. Okay, questions about that? So I took a delta and I made it into a Y. The other way I could do this is I'm going to take that Y at the bottom and make it into a delta. So I'm going to have 40 volts, 28 ohms across the top, and 10 ohms over here, plus minus V1. And then that Y in the middle becomes a delta. So if I call this A prime, B prime, and C prime, this is RC prime, RA prime, and RB prime. This is two different ways to simplify the circuit. Yes, talk to me.
Is the labeling that you did, like B prime, C prime, and D important, or is that just kind of what you do?
I'm doing that because I want it to be consistent with the diagram that we use. So if you flip back over here, when I make the conversions, it's A, B, and C, right? Since I'm doing it twice, I don't want you to mix up A, B, and C. So for the second one, I just made it A prime, B prime, and C prime. But I'm labeling R1, R2, and R3 to be consistent with this, and RA, RB, and RC to be consistent with that, okay? So I need to find R1 first. So R1 is going to equal 16 times 28, the product of these two, divided by 16 plus 28 plus 60. R1 is 16 times 28 divided by 16 plus 28 plus 60. In other words, it's RB times RC over RA plus RB plus RC. What is R1? What is R1? 4.3 ohms. Okay, I'll go with your answer. You're the only one that answered me, so let's assume it's right. All right. R2 is going to be RC times RA over RA plus RB plus RC. So the denominator stays the same. So the denominator is still 104. Oops, sorry. Thank you. The denominator stays the same. So the denominator is still 16 plus 28 plus 60. What is that? 88 plus 16? 104, right? 104. And the numerator is 28 times 60. 28 times 60. What is R2?
16.
Exactly 16 ohms? 68 ohms. 20 times 60. 16.15? I told y'all I couldn't hear, little haters. 16.15. Okay. Okay. How are we doing so far? Everybody doing okay? Now we just plugging and chugging. Choo choo. Plugging and chugging. Okay, R3. R3 is going to be RB times RA over RA plus RB plus RC. So that's going to be the product divided by 104 again. And it's B times A, so it's 16 times 60. What is R3? 9.23 ohms. Okay. So now I'm going to simplify my circuit again, and then use that simplified circuit to find V1. So my next step is going to be 40 volts, R1, which is 4.3 ohms. Then I'm going to have 30 plus R3, 39.23 ohms. And over here, I'm going to simplify this down to one resistor, which is going to be R2 plus 10. R2 plus 10 is 26.15 ohms. Okay. Let's understand where I got that from. This is R1. This is R3 plus 30. And this is R2 plus 10. Okay. I want to find V1, but I'm going to use this circuit to find V1. So, for example, I can call this V2. And then I'm going to use V2 to find V1. So that's going to be V2, and I'm going to use V2 to find V1. Are there any questions? I'm going to use my favorite law to find V2, which is the voltage divider. So V2 is going to equal 39.23 in parallel with 26.15 divided by 4.3 plus 39.23 in parallel with 26.15 times 40. V2 is 39.23 in parallel with 26.15 divided by 4.3 plus 39.23 in parallel with 26.15. I need somebody to tell me what V2 is. 1.3? 9.3. It's also the mask. Yeah, I can't hear that great, but you also have mask on. All right, 9.3. Oops, 9.3 volts. All right, finally, we're ready to get V1. So that node here is the same as this node here. So that means V2 right here is 9.3 volts. This is 9.3 volts. That node is the same as this node. If that's 9.3, that's 9.3. If that's 9.3, that's 9.3. So V1, I can find by doing another voltage divider. I need this to go out more because I hate moving back and forth. Okay. So what is the voltage divider formula to find V1 if I know that it's a 9.3 volt across two series resistors? V1 is the voltage across the 10 ohm. How do I find that? 10 is going to be the numerator, divided by 10 plus what? 10 plus R2, which is 9.3. Oh, that's not 9.3. What's R2? Sorry. 16.15. Sorry, my bad. 16.15. Okay. Why don't any of these pencils have erasers? Guess because I used them all. All right, make sure you put 16.15 on your paper while I fix this. Times 9.3. All right, somebody tell me what the answer is. What is V1? 3.56 volts. That don't sound like what I got last time, but you know what? Who cares? Let's keep it going. You understand the concept, because if we don't get 3.56 when I do the other side, something's rotten in Denmark. Okay, 3.56 volts. Questions? I'll be a... Okay, let's step back here. This is all about trust. What is V2? Anybody else get 31.4? Anyone else get 9.3? That's rounding. All right, Kareth, we're going to change this to 31.4. Check it. And then we need to change this one to 31.4. Okay, tell me what you get for V1 then. What's V1? 12.2? 12.2? Yeah, I knew the answer was an integer. I like that better. So V1 is 12. Okay. So think about this on your exam. You got to make sure that you can put things in your calculator correctly, because garbage in, garbage out. It's not, you don't understand the concepts, but if you get all the way to the end and type something in wrong, whoo, honey. Okay. I do get partial credit though. You won't get the whole problem wrong just from a number, but carrying a wrong number through to the end is just exploding, right? All right, let's keep going. So now I'm over here. And you good? Okay. Oh, okay. So over here, this is now R1, R2, and R3. Maybe I'll put primes on them so you'll know. R1, R2, and R3. So R1 prime is 16 ohms. R2 prime is 6D ohms. And R3 prime is 30 ohms. All right. So once I did it, this is R1 prime, R2 prime, and R3 prime. So I don't have this side memorized, so I have to look. It's not bad though. So RA prime is R1 prime, R2 prime, plus R2 prime, R3 prime, plus R3 prime, R1 prime, divided by R1 prime. Okay. So it's 16 times 60 plus 60 times 30 plus 30 times 16 divided by 16. 16 times 60 plus 60 times 30 plus 30 times 16. I know that's tiny, sorry about that. Divided by 16. What is RA prime? 202.5, okay. And then it's the same numerator again, but now it's that numerator divided by R2 prime. $54. Okay, what's the numerator? Do you know what the numerator is by itself? 3240. Okay, the numerator is 3240 divided by R2 prime. Okay. And then what do you think the RC prime is going to be? 3240 divided by what? Divided by 30, yes. 3240 divided by 30 is 108. 108. Okay. All right. Any questions so far? I'm going to need another sheet of paper. I can see that already. Okay. So, yes, talk to me.
Will it be easy for us to figure out, so like when you change from the top to either a Y or a delta, to figure out which is supposed to be?
Yes, everything I'm doing, this is my guide. I give you this picture on the formula sheet. All right. I use this. That's how I'm determining 1, 2, 3 and ABC and all of that. Other questions? Okay, so now I'm going to redraw this like this. I'm down to 1 voltage source and 3 resistors. I have 40 volts in parallel with 54 ohms. That top resistor is 28 in parallel with RC prime. Uh-oh. And that right resistor is 10 in parallel with RA prime. The parallel with the voltage source is 54 ohms. The top resistor is 28 in parallel with RC prime. So it's 28 in parallel with 108. What is 28 in parallel with 108? $22.2 ohms. I need you guys to start confirming before we get too far down the rabbit trail. So if the 22 don't work for you, let us know, okay? 10 in parallel with RA prime is 10 in parallel with 202.5. 10 in parallel with 202.5. 9.53 ohms, okay. So now this is V1. So V1 is 9.53 divided by 22.2 plus 9.53 times 40. V1, the voltage across the 10 ohm resistor, is equivalent to the voltage across the 10 in parallel with the RA prime. So it's going to be 9.53 divided by 22.2 plus 9.53 times 40. Somebody tell me V1 is 12, please. If it's not, we have a mistake somewhere. If V1 is not 12, then we are not happy campers. Wah, wah. Is it 12? Woohoo! It's 12. So 2 different ways of solving the same problem and getting the same answer. Questions? So that takes care of part A. Part B says, what is the power delivered by the voltage source? I can use any of these simplifications to answer this question because I haven't made any changes to the voltage source. The easiest thing to do is to find the current through the voltage source. The current through the 54 ohm resistor is 40 over 54. The current down through the 54 ohm resistor is 40 over 54 because it's in parallel with the voltage source. Jackie, Onassis, Courtney, are you Courtney? Okay, good. All right, 40 divided by 54. The current down through the 10 ohm resistor is 9.53 divided by 10. 9.53 divided by 10. I want you to tell me those 2 currents because we're going to use those 2 currents to find the current through the voltage source. The current up through the voltage source is going to be the sum of 40 divided by 54 and 9.53 divided by 10. The current up through the 40 volt source is 40 divided by 54 and 9.53 divided by 10. Why is it divided by 10? Because we had that the voltage across the 10 ohm resistor, oh, it's 12, isn't it? Where did I get 9.53 from? Pray for me, honey. 12 divided by 2. Sorry about that. 12 divided by 2. 12 divided by 10. I just wanted to see if you're paying attention. Megan, why are you frowning at me? 12 divided by 10. It's hot. And I'm in a mask. And I'm talking for 36 minutes straight. Pray for me. Pray for me, EW. All right. What? I'm gonna have to make this pretty. I'm jacking you up. I'm jacking you up, Megs. Let's just make a pretty piece of paper. I was trying to squeeze it all in there and it's jacking you up. Here, let's do it on here. You're like, what? This is V1, yeah, and this is 10 ohms. You agree with that?
That's the 9.53.
Oh, good Lord.
That's what I was confused with 10 came.
Yeah, because it's all that. This is why I tell y'all not to write in ink and not to write messy, because you can't read nothing and you start making mistakes. Oh. So what's the current here? 12 divided by 9.53. Sorry about that. Sorry. I can't read my handwriting up here. It was messy. That's why you write over nice and pretty and neat. Okay. Sorry, EW. Okay, so this current is 40 over 54, and this current is 12 over 9.53. Is everybody good with that? Okay, so that means that the current up through here is what? 2.03, let's just say 2 amps. So what is the power delivered, which was the second half of this question? 40 times 2, 80 watts delivered, right? So once again, what we did was we summed the currents at this node using KCL so that the current from the 40 volt source was 40 over 54 plus 12 over 9.53 to get the 2 amps. Questions? Going once? Going twice? Gone. Remember, Wye-Delta Transformations is the first question on midterm 2. Okay, the first question on midterm 2. Midterm 2 will be on October 8th. But who cares about that when you have one on Monday, right? Okay, moving on. We're starting a new topic. It's called the node voltage method. So the node voltage method is based upon Kirchhoff's current law. So the node voltage method is based upon KCL. So it's really important that you're able to recognize nodes because you can't do KCL if you don't know where the nodes are. We use the node voltage method on circuits that are planar, which means no crossing branches. I actually don't give you non-planar circuits because it's too hard to do anything with them, okay? And the way you do this is we identify our nodes and then we sum the currents into and out of those nodes in a systematic way, and it's called the node voltage method. And you find those node voltages. So a node is a meeting point of 2 or more circuit elements. How many nodes are in this circuit? Do not count the dots. That's another thing students love to do is count dots. The dots just indicate connection points. They do not indicate nodes. How many nodes are in that circuit? How many nodes? Circle them. Do not count the dots. How many nodes? 4. There's 4 nodes. 1, 2, 3, 4. There's 4 nodes. Do not count the dots. It just so happens there's 4 dots. Yeah, that's right, because notice there's 2 dots inside of one of the nodes. Okay? An essential node is a node where 3 or more circuit elements connect. So there are 3 essential nodes. The essential nodes are here, here, and here. Okay? Basically, what that's saying is that whenever you have series elements, they're at non-essential nodes. That's the same thing, right? So if only 2 elements meet at a node, it's called a non-essential node, and it means those elements are in series. The only reason you care about that is because when you're doing KCL, you don't necessarily have to do it at that node. Because once I find the current at this node, it's the same as the current there. So it's called a non-essential node when you're doing KCL, because those are in series. Questions? Okay, a path is a trace of adjoining elements, including none more than once, right? So I normally don't cross over nodes to do this. So I would say that my paths are this 10 volt to this 1 ohm, the 5 ohm, the 2 ohm, the 10 amp, and the 2 ohm, right? So a path would be adjoining elements with no element crossed more than once. So I'd say one path would be the 10 volt to the 1 ohm. Then the 5 ohm by itself, there's nothing in series with that. The 2 ohm by itself, there's nothing in series with that. The 10 ohm by itself, nothing in series with that, and the 2 amp by itself. So I would say that there are 1, 2, 3, 4, I can't count today, 5 paths. Same. So any circuit elements can be a path, right? But I normally only do paths that connect essential nodes, because if you don't do that, there's billions of paths. But those are the ones I care about, because I'm then going to talk about branches. And branches of the circuit are really just the circuit elements. So any element that connects to nodes, which would be all of them, I would call a branch. So the difference between those two things is the circuit elements, right? So in other words, the 10 volts by itself could be a branch. The 1 ohm by itself could be a branch. The 2 ohm by itself. So it's everything except now the 10 volt and the 1 ohm I'm separating. Yes?
So like on the one where we did that had like a hanging branch, would that not be considered like the hanging?
That resistor? That would still be a branch of the circuit, right? It's just not closed. But you know what? No, I wouldn't call it one because it doesn't have a node on the other side. Okay, so that would be a no on that one. Okay. So any branch, a path that connects 2 nodes, I would count all of them and say if there were 6 of them. 1, 2, 3, 4, 5, 6. I'm basically counting the elements. Still don't get it. Okay, let me start over. So there's lots of paths in a circuit, right? Because I could count all of them. I could say the 10 volt to the 1 ohm to the 5 ohm is a path. Or the 5 ohm to the 2 ohm to the 10 ohm is a path. Or the 10 ohm to the 2 amp. So as long as I stop and start at different nodes, it's a path in the circuit. Does that make sense? But I'm only interested in the ones that don't cross over a connection point, because those are the ones I'm going to end up using for my KCL. Right? So a path is any connection point where I don't go back to the same node. I don't use it more than once. So I can start at the 10 volts, go to the 1 ohm, go to the 5 ohm, and that's considered a path in the circuit. But 10 volts to the 1 ohm is also a path in the circuit. All right? 5 ohm to 2 ohms to 10 ohms is also a path in the circuit. 10 ohms to 2 amps is a path in the circuit. So all of those are paths. So that's why I'm saying there's millions of paths. But I only really care about the paths that I'm going to end up using in a minute when I do KCL. Okay, so then a path that connects two nodes could be the 10 volt by itself that connects two nodes. The 1 ohm that connects two nodes. The 5 ohm connects two nodes. Every element's going to connect two nodes. So essentially, that becomes the circuit elements. So if I have 1, 2, 3, 4, 5, 6 circuit elements, that would be the branches of the circuit. Circuit elements and branch I use interchangeably. Every element is a circuit branch. Does that make sense? I'm sorry? Okay, let's keep going and just let it marinate, okay? So an essential branch is a path which connects two essential nodes, right? So the 5 ohms is an example of an essential branch, right? Because this is an essential node and this is an essential node. The 2 ohms is an example of an essential branch because it connects two essential nodes. The 10 ohms is an example of an essential branch. It connects two essential nodes, right? And the 2 amps. Why isn't the 10 volts an essential branch? The node at the top is not essential. And the 1 ohm is not an essential branch because that left node is not essential. So just like I was saying a minute ago, when I do KCL, I don't have to use this one because I can get the currents at one of the other nodes. Okay. Sometimes you got to stare at it for a minute. Or not. Right? All right, we're going to finish loop and mesh, and we're going to stop there because we only have 3 minutes left. A loop is a path whose last node is the same as the starting node. How many loops are there in this circuit? How many loops? A loop is a path whose last node is the same as the starting node. There's 6, right? So the 6, and also I didn't answer this one. There were 1, 2, 3, 4. Okay, so it's 1, 2, 3, 4, 5, and then the whole thing is 6. There's 6. The meshes are the windows to the circuit, right? So a loop that does not contain any other loop is called a mesh. The meshes are like the windows of the circuit. How many meshes are there? A loop that does not include any other loop. There's 3. Okay, there's 3 meshes. So yeah, we're going to stop here. We'll do some examples of this. But there's a section in your book that actually talks about the difference between paths, branches, essential branches, and essential paths. I want you to go look at that, okay? The main thing I really care about is essential nodes and meshes, because that's what we use to do node voltage and mesh current.